Artemis Intelligent Power was a company that we spun out of the University of Edinburgh in 1994. There were a lot of renewable energy projects on the go and no realistic way of matching the movements that natural forces bring to the movement that a generator that makes electricity requires.
Digital displacement technology replaces the conventional analog mechanisms of hydraulic machines with a completely digital control method. Each working chamber of the machine is provided with a solenoid-controlled valve, which is controlled by an embedded computer which is synchronized to the rotation of the shaft. Every working stroke of our machine is controlled in real time by a computer.
Of course, this technology didn't exist. It was really by making first small demonstrator machines and understanding what the technology can do that we realized how big the potential is.
For the first wind applications, we wanted to do something big straight away. And so we were looking at several megawatts right from the very beginning, using a ring cam pump. And you were choosing what fraction of the pumping modules you want to deliver the power. So you've got variable speed input and absolutely fixed phase frequency output.
One of the most impressive aspects of the technology is really the way it's designed. So the 7 megawatt transmission is made of many modules of the same, say 100 kilowatt. And if anything happens to any of these modules, they can simply be disabled and everything else continues working.
I think the very exciting thing about digital displacement technology is that it can be applied to so many different markets. And apart from the environmental benefits from this technology, it brings employment. It's great in a way to see that it is possible in the UK to build a company that can develop but also manufacture and enter into world markets.
Endomag is a medical device company focused on improving the standard of care for breast cancer. 1 in 8 women will be diagnosed with breast cancer in their lifetime, but only 50% of those patients will achieve the best standard of care. What Endomag is set up to do is to apply some new technologies to making the best standard of care available to everyone, everywhere that we can.
The story of the creation of the Sentimag probe comes from our observing a real clinical need, and we thought that we had a way to do that using magnetics rather than radiation. The idea behind the Sentimag system is that we inject magnetic particles into the breast, then we trace the way that those particles move through the breast into sentinel lymph nodes in the armpit area.
The thing that really makes it stand out is the tremendously small signal you're seeing against a very large background. And we're talking about signals that are perhaps 10 million times smaller than the background. And being able to pull those signals out is very, very demanding, and at the same time making a probe that's actually small enough for the surgeon to conveniently use, and also can be used without having to be in a screened room or anything special. It can just be used directly in the operating theatre.
It was necessary to bring different expertise in engineering, clinical, regulatory, and even device development expertise, and leverage that with the in-house knowledge, and also by forming partnerships to develop this technology. At the end, the technology offers significant improvement over the existing practices, at significantly reduced cost, and improve accessibility to sentinel lymph node biopsy procedure to hospitals and communities that do not have access to nuclear medicine facilities.
On the commercial side, we've been successful in establishing a distribution partnership in Europe that has meant that we've now treated 5,000 patients who wouldn't have received it otherwise.
We're really pleased to be manufacturing almost exclusively in the UK. Even if the raw material is manufactured abroad, it's formulated and packaged here in the UK. Having a local supply chain, not only in terms of development of those or manufacturing of those products, but also utilize local relationships for continued R&D.
We're on our way to get there. We're already into the thousands of people having been operated on. It'll be tens of thousands, it'll be hundreds of thousands, and it'll be millions.
Victrex is a British manufacturing company, and it's a unique company. We have 700 people totally focused on addressing our customers' challenges and finding and delivering solutions that create value for them, for us, and for our shareholders.
So Aptiv Films was a concept. We didn't have anything like Aptiv Films here 8 years ago, and it's been grown from the ground up.
Aptiv Film is based on Victrex Peak, as it utilises the material and performance benefits that you get inherent in the Victrex Peak polymer, but it's converted into the film format which the customers can use in highly demanding applications.
Aptiv Film technology has been able to replace the insulating materials used between the cabin of an aircraft and the outside skin. These insulating materials will be requiring certain properties: lightweight, strength, and some degree of low toxicity in the event of a fire. A second application has been mobile technology such as mobile phones and tablets, and as the device has become thinner, so has the component, for instance the speaker, for which we produce film that gets used to produce those speakers.
We are a new player for speaker market. We try to penetrate this market, and we work with the experienced people, and we learn the acoustic technology. At the end, we can speak the same language with our customer. We tell them how to use it, what is the process, what is the tool design, and they can achieve ultra-thin speaker for smartphone.
Many times you're doing applications that have not been done before, so you have to look at some of the trends and look ahead and make the view that they're going to need this in a few years' time. And that's what we did, and that's been part of the commercial success. No one had actually done this before at this scale. There was a lot of small innovations along the way that we had to overcome problems to get it working. All of those innovations cumulatively have given us quite a lot of breakthrough where we've got a world-leading material.